Sorry, I'm getting all tangled up with some cords here. Just a second. And I'm blurry. Okay. All right, everybody. Welcome in. I haven't been getting any questions about the homework that's about to be due, so I am assuming we're comfortable with that stuff. So I want to move ahead into the material coming up. I do still have office hours tomorrow, so if you're trying to do some of this homework that's about to be due tomorrow and you're having trouble, come to office hours tomorrow. I can help you out with that. Otherwise, we'll move ahead. So the course takes a little bit of a turn at this point in difficulty, in that it's a bit of a step up. And I think it's fair to say that each of the chapters that we've been doing so far is already a little bit of a step up in difficulty. But I guess what I'm saying is I think the step up in difficulty is a little bigger starting now for this chapter. It went from the last couple of chapters had lots and lots of little details, but each individual detail wasn't too bad, right? Complex numbers has a whole bunch of stuff you got to keep track of, but once you understand the basics and you've done the homework, people tend to do pretty well with complex numbers. Same with that whole last chapter with radicals. Lots of little things about, well, when can I add square roots together? And oh, these square roots don't look like they can be added, but oh, that's right. If I simplify first, then maybe I can add them together. And what about when I'm multiplying square roots? And then you have the square roots with equations and stuff. So lots of little details, but each individual detail is not too bad. We're kind of getting into this next chapter where there's a few big ideas. So there's less concepts, but each one is sort of it takes more work to get through. So I'm not trying to scare anybody. I just want you to kind of know what you're getting into. This next chapter, like right out of the gate, we're going to see 3 or 4 big things, and each one of them is not just like, 3-4 lines and you're done with that problem, right? Right. So we're getting into problems where all of a sudden now you could easily, it's like some of these problems, you might write 15, 20 lines before you solve some of these quadratic equations, right? That's a big step up in complexity from, remember when the quadratic equations we've solved so far that we solved from factoring, those, might have taken you 4 or 5 lines, 6 lines to finish. So it's, I'm not saying that stuff was easy, but obviously if we're jumping to something where a problem might now take you 15 lines to complete on your scratch work, it's a big step. There's a lot more going on that you have to think about before you complete the problem. One thing that I will say helps, just write stuff down. I know I sound like a broken record. I honestly, if I could snap my fingers and students would write down more when they're doing math, all my grades would just rise, right? So that's one of the keys. It doesn't save you time to not write stuff down. It actually saves you time to write more things down. So don't try to do 3, 4, 5 steps each line because you want to write less. Just do one thing at a time, right? Making a mistake in these kinds of problems costs you a lot of time because you have to go back and redo so much work. You're much better off just do one thing at a time that you can get right. Write another line down. Okay, I got this one thing to do. Okay, write that down. And then you get to the end, and just that relief of not having to do the problem over again will be worth it. Okay. So yeah, that's good. So some people saying it's, stuff's challenging, but they're sticking with it, and it's good to get the brain going. That's good. That's good. That's the right attitude. This stuff is challenging. I mean, how many times most of the time in life, things that actually benefit you they're difficult to do. There's, if you're getting a payoff from it, they're challenging. And I'm not trying to scare everyone. You all can do this. If you've hung into this course to this point, you can finish. You can do the rest of it. But if you're hitting like all of a sudden you go to do the homework for these and you're like, man, this seems like it's hard, just realize it's not you, right? It's not that you sort of can't do the stuff all of a sudden. It's that these problems are harder than what we've been doing so far. So just stick with it, work through it, and you'll be good. But it does take a little bit of work to get through. Now, we'll start off with stuff that doesn't seem too bad, and then we'll build into a couple of concepts where you're like, well, there's a lot going on here. Okay. So like solving quadratics, super important. Okay, there's a lot of formulas in physics that are quadratic formulas, like for gravity. Gravity oftentimes is represented with quadratic equations, so that is second-degree polynomials. If you take a business calculus class, a lot of times your profit and revenue and cost, these are all going to be represented with quadratic equations. So a fairly important family of equations, and we want to solve them. Why? Well, if I'm a business, I want to know what number of units produced will maximize my profit, right? We want to be able to solve that because, of course, if I'm a business, I want to maximize profit. Doesn't that sound good? Well, we've got profit. Should we try to maximize it? Well, yeah, we're a business. Let's do that. A lot of times people think, well, if you produce more product, doesn't that mean that you're going to sell more, which means you're going to make more profit? Just create more product. Not necessarily. There's usually costs are variable with things, and sometimes you actually reach a situation where usually when you buy more of something, you get a better price on it. But sometimes if you buy so much of something that you make that item scarce, then the price of it goes up again, right? You might a lot of times hear about lithium. Lithium is an important element for a number of reasons. It has it sometimes gets used in medical stuff. It's oftentimes used in batteries. We're trying to electrify things so that we're not using as much CO2. That oftentimes involves batteries, so lithium is very important. Lithium is one of those things where when we run a scarcity of it, the price goes up, right? So you might be a company that makes batteries, and you may be able to get your hand on a certain amount of lithium at a reasonable price, but if you just keep ordering more and more lithium and then we run into a shortage, all of a sudden you're paying more for lithium. Well, if you're paying more, that means your profits can actually shrink, even though you're selling more product. So if we can write a quadratic equation that predicts next month this will tell us how many units to produce in the next month to maximize profit, then that's what you want to do. Right? Why would you want to do more work and make less money? You don't. You want to get right to that point that maximizes your profit and go, nope, that's the best we can do. Let's take the rest of the week off or whatever, right? So, and this comes up in all sorts of settings, science and all sorts of stuff. So solving quadratic equations, really, really important. And you've solved some quadratic equations, but you were limited. When you solved quadratic equations, you were solving quadratic equations by factoring. Now, that's fine. That's actually the preferable way to do it, but there's a limitation there in that if you're going to solve a quadratic equation by factoring, that quadratic equation needs to be factorable, right? Remember, not everything is factorable. So if I hand you a quadratic equation that can't be factored, you're just going to look at me and go, well, I can't factor it. I don't know what I'm supposed to do here. And that's right, because we haven't learned it yet. So what we're going to get into now is, what do you do when you have a quadratic equation that you want solved, but it is not factorable? So we are going to expand the number of quadratic equations that you can solve to the point where we can solve any quadratic equation. The tools that we'll be learning in the next couple of class meetings can solve any quadratic equation. That's much better than factoring that can actually just solve a select few. Now, you still want to always try to solve a quadratic equation by factoring. Like, you always want to check first, is this factorable? Because even though it may not have seemed like it at the time, you will see quickly it's much easier to solve a quadratic equation by factoring than using these other techniques. So it's the preferable method, but you will run into situations where you can't solve it by factoring because it is not factorable. Therefore, we will bring in completing the square, quadratic formula, those kinds of tools, which are much heavier machinery. Takes a lot more to wield the quadratic formula, right? But it will work for you. And that's kind of how it works sometimes in mathematics, is we have these tools that work every time, but they're like a lot of work, right? So we have these kind of nice shortcuts that work occasionally, but then you need to know what to do when that easier way of doing something doesn't work. And the concept that I just explained still throws people off. Even in my business calculus class, I'll have students go, I don't know how to solve this equation. It's not factorable. Well, remember, you got the quadratic formula. And they're like, oh, I got to use the quadratic formula? Yeah, you do. So it's important, and that's where we're building to. I'm not sure how far we'll get today. I don't know if we'll get to the quadratic formula today or not. We have to build our way there. There's actually like 3 big topics we're going to hit here, and the third one is the quadratic formula. So we're first going to start with the square root property. Then we're going to get to completing the square, and then we're going to get to quadratic formula. And we'll just see how long it takes us to get there. But each point along the way, we're going to, you'll see, the complexity of the problems we're doing, they're going to get more difficult. But also, it's empowering because now we can now solve equations that, tomorrow you will be able to solve equations that you could not solve yesterday. So that's helpful. So let's get started here. Let's get to the first one, which is the square root property. In fact, I should have had my book ready. Square root property, I just want to make sure if I make up my own wording, it could be kind of sloppy. Let me just make sure I do it. Let me look it up in the book so I make sure I use the nice, clean, efficient wording they use in the book here. Right. So this says, and then I'll explain it. So at first when you look at it, you're like, I'm not really sure what that means. We'll go over it. So we say if any non-negative real number, and we'll just call that real number C. Oh, 4, not if, 4. For any non-negative real number C, if, that's where my if goes, if x equals the square root of C, so we had to learn all that square root stuff in order to make sense of this chapter. Oops. Writing the wrong part down. If x squared equals C, then x equals the square root of C, or x equals the negative square root of C. Okay, so that might look kind of confusing at first, but let's sort of put a number in here, and I think it'll help make sense of this a little bit. So let's do like an example of what this would mean. So let's pick a number. So how about if I say if 3 squared is equal to 9, then x equals the square root of 9, then 3 equals the square root of 9, or 3 equals negative square root of 9. So this is what you should always do. When someone presents something to you with mathematics that you don't understand, try to make an example. I mean, I did this in grad school all the time. You're reading, you're doing research, so you have to read some paper that has to do with your research, and you can't make sense of it. So you just make an example that fits what they're talking about, and you go, oh, okay, I get what's going on here. So if 3 squared is equal to 9, then 3 is equal to the square root of 9, or 3 is equal to negative times the square root of 9. In other words, we could rewrite this with negative 3 squared equals 9, right? Those are your two options. So basically, we're just saying it's just putting into formalization the idea that when we square things, you're going to square the value of the number, and then you could have started off with a positive or negative. In other words, 3 times 3 is 9, Negative 3 times negative 3 is 9. Both of those numbers, when you square them, you get 9, right? So what if I wanted to solve the equation? Let's leave a variable in this time. X squared equals 9. Well, what are the things that can be equal to? Well, x can be 3, or x can equal negative 3. Those are the values that can take on, right? As soon as it compiles here. Oops, wrong slash. There we go. Those are the values that can be taken on, either 3 or negative 3. So this seems obvious here. Yeah, okay, well, the things we square to get 9 are 3 or negative 3. That seems okay. But wait till we start putting algebraic expressions in there. It's not going to be quite so obvious. So that's why we start with an example like this. If you can understand the simple examples, you can understand the more complicated ones. This is a thing I see people do wrong when they're trying to learn mathematics, is they skip ahead of the simple examples and they're like, yeah, I know that the square root of 9 is 3. Yeah, like, I get it. We don't have to go over that example. But then when they get to the hard examples, they don't know how to work through the problem. The reason we show you simple examples isn't to show you that particular problem. It's to show you the process of how you move through a problem, because then when you get to a hard problem, you're like, I don't know how to do this, but I do know the process. And then you follow that same process all the way through. This is the problem when people start viewing math as like the answer is what's important. The answer is important, but it's not the thing that's important. If you think 100% of the importance is on the answer, then you're missing the procedure along the way. And that understanding the procedure is what's going to help you when you get to the hard problems that you don't know how to do. You go, well, I do know the procedure, so let me just follow that procedure, and I work my way through the problem. Okay? So let's say we have something even a little more difficult. Let's ramp it up a little bit. Let's say I've got x squared minus 12 equals 0. Oops. Hit all sorts of wrong buttons there. Let's see. Okay, x squared minus 12 equals 0. Okay. Well, now see how we've raised it a little bit? I go, well, okay, so that's not factorable. We don't know how to factor that. That's not a difference of squares. Okay. That's not helpful. And then also it's harder than the example we just looked at, right? But we need to know the process for how to do this. So what we would do then is we would try to put this in the form of this formula. Well, the formula we're given wants things in the form of something squared equals a number, right? Some quantity squared equaling a number. Well, that's not what we have. We have a quantity squared minus a number equals 0. So we have to work to put this in the right form. This is a lot of you will do this going forward. A lot of you who end up in calculus, this is a ton of what you do in calculus, is you have a formula that you want to use, but the problem you're working on doesn't fit that formula, so you do a bunch of algebra in order to get that in the right form, and then you like apply the formula and it does everything for you. But you had to do a bunch of algebra to get to that point. That's why a lot of people don't realize. A lot of people who don't pass calculus do it because they don't know their algebra. It's not that they can't do calculus, it's that they can't do algebra. So all the algebra you have to do to apply the calculus, they can't do that. So this is kind of our focus. How do I put this in the form of x squared equals c? Well, why don't I add 12 to both sides? See how now it's in that form? X squared equals 12. So I've added 12 to both sides, and now it's in the form x squared equals c. Our c is just the number 12. That's all. Okay, all right. So then what does this say? Well, it says that then, if this is true, then x is equal to the square root of 12, or x is equal to negative square root of 12. Okay, so let me see. Let's do that. So then that means that x equals the square root of 12, or x equals negative the square root of 12. Now, hopefully, most of you are comfortable enough with that last chapter we were working through to go, Do I need to keep going or am I supposed to stop here? Well, it's like anything that's not fully simplified, simplify it, right? Hopefully you recognize the square root of 12 is not a simplified quantity. So should you simplify it? Yes. Yes, you should. So remember, the square root of 12 can be broken down into the square root of 4 times the square root of 3. Square root of 4 becomes 2. So let me know if I'm jumping too many steps here, but hopefully people are okay with this. This becomes 2 times the square root of 3, or x equals negative 2 times the square root of 3. Okay, right? Remember, square root of 12 becomes square root of 4, square root of 3. Square root of 4 becomes 2, so you get 2 root 3. Just simplifying 12, like from the last chapter. So here's your answers. Remember, for a quadratic equation, we should get 2 answers, and we did. Oops, but I have a typo here. I can't seem to hit the right buttons today when I'm typing. 2 square root of 3 and negative 2 square root of 3. Those are my two answers. Now, we have a special symbol that I see students use, but they don't always understand what it means. We have a shortcut way of writing this, which just makes it a little bit easier. We can write this as x equals plus or minus 2 times the square root of 3. So see this plus or minus symbol? A lot of students, they're like, oh, I just know to write that plus or minus because I always see it in this part of the problem, but they don't really get what it means. It's just a shortcut for the line above it. See how much shorter it is than the line above it? But the line above it says it's either the positive 2 square root of 3 or the negative 2 square root of 3. Well, we just sum that up with this plus or minus. It just saves us a little bit of space and writing and talking, the amount of words we have to say. It just shortens it a little bit. It's a little shortcut. But that's all it means. It's a shortened way of writing this. We just say it plus or minus. X equals plus or minus 2 times the square root of 3. That means positive 2 root 3 and negative 2 root 3 are both the solutions. Okay? So that's just directly applying the square root property to an equation. Now this is an equation you couldn't have solved before. You didn't know how to solve an equation like this 10 minutes ago. Okay, but now we do using this square root property. Okay, but we can even extend things a bit more. Right? You're going to see in this chapter, we start bringing in all sorts of stuff from earlier chapters. You just saw us using the radicals, the roots. You're going to see complex numbers showing up. You're going to see fractions showing up and factoring and all sorts of stuff's going to come into play in this chapter, which is actually kind of nice because it's going to help you practice those earlier skills that you probably learned but maybe are still a little uncomfortable with or a little unsure about. You're going to be using them so much you're going to get very confident with all of those rules. Okay, so let's do this one. We're not in any rush. We got plenty of time. So let's say we've got 4x squared minus 25. Nope, plus 25. Minus 25 would be factorable. Plus 25 equals 0. And we want to solve this. Okay, so the directions would be to solve. We go, okay, well, I'm not going to be able to factor it, so I guess for now I'm going to have to use that square root property. Okay, so do that. So you go, let's get it. Remember we want it to be something squared equals a number. So just like last time, I want to get that 25 on the other side. So I have 4x squared equals negative 25. So I subtracted 25 from both sides. You go, okay, are we ready to use the square root property? No, not quite, because we're supposed to be in the form where it's something squared equals a number. But we don't have that yet, right? We have 4 times something squared equals a number. But that's not what our theory said, right? What our theorem said. So remember, this is what I mean. Like a lot of, even in calculus, a lot of your algebra is prepping the problem algebraically so that you can actually then apply some formula. That's what we're doing here. I'm prepping this problem to put it in the right form so that I can apply the square root property. We'll come up with an even more complicated way of doing that in a few minutes. Maybe next week. We'll see where we get on time. Okay, so then what do I do? Well, if that 4 is causing us a problem, what do I do? Well, I get rid of it. So how do you get rid of a multiplication by 4? You divide by 4. So this will become, and some of you are getting nervous because you're probably starting to see that we're about to introduce fractions in here. That's okay. Don't panic. You know how to deal with fractions. You'll be okay. So what do we have? Negative 25 over 4. Okay, now we have, oops, I put too many negatives in there, didn't I? Let's get rid of this one. So as soon as that compiles, we have what we need. We have x squared equals a number. Okay, now I can apply that square root property. So the square root property says, well, in that case, x will be equal to the square root of 25 fourths, or x will be equal to negative the square root of 25 fourths. Oops. Nope, I'm missing my negative, aren't I? This should be, hold on one second. This isn't right. This should be a negative here, a negative here. I put my negative in the wrong place. There we go. Right? So the negative's still there. So x is equal to this, the square root of this number, or x is equal to the negative square root of this number. Notice these negatives don't cancel. Remember, a negative inside of a square root is not the same as a negative outside of the square root. They don't cancel the same way. So what happens when I simplify negative 25 fourths? Well, that's what we looked at last time. We're going to get a complex number. If you take the square root of a negative, you're getting a complex number. So remember with fractions, you take the square root of the top, square root of the bottom, and if you're taking the square root of negative 1, it becomes an I. So this would become x equals 5 halves, right? Square root of 25 is 5, square root of 4 is 2, 5 halves, and then we have that I in there representing the square root of the negative 1 that would be occurring right here. So that's this part. But then also we have the negative of this. So we have the plus or minus version of this. In other words, it's plus or minus that. So I forget if Delta Math likes you to use plus or minus. I forget if they have a plus minus button or how it works. So just pay attention to how that wants the answers for things. If it wants you to write them out, 5 halves I, comma, negative 5 halves I, or if there's a plus or minus button in there. I can't remember because some softwares have it and some don't. But that's it. We got two answers, 5 halves I and negative 5 halves I. Those are our two answers that we get for that one. Okay. Any questions? I'm not seeing any questions. We're good. Okay, let's step it up a little bit more then. All right, let's take something like the following. Let's do this. X minus 1 squared equals 15. Okay, so, now the thing that's being squared is a binomial. Well, that's okay because up here where we were saying x squared equals c, x can stand for an algebraic expression as well. So we can actually already just immediately apply it to this right here because we'll apply it to the thing that's being squared. Okay, so applying the square root property here says, okay, well then that means that x minus 1 is equal to the square root of 15, or x minus 1 is equal to negative square root of 15. See how I'm applying it right here already? I know it's weird. The fact that there's a binomial there throws people off, but the whole algebraic expression can be squared and we can still apply that square root property. Okay, and then from here it's pretty easy to solve each of these. We're just going to add 1 to both sides of both of these equations. In doing so, I will get that x equals 1 plus the square root of 15, or x equals let's see, 1 minus the square root of 15. Oops, I missed the 1 entirely. Okay, so step 1 here, I applied the square root property. Step 2, we're solving each of these equations for x. And then look, we haven't used this quite this way before, but you can see that we can now write this as x equals 1 plus or minus square root of 15, right? This is the shortened way of not having to write it out 2 whole times. We just put the plus or minus there, and it means, well, we've got the 1 plus square root of 15, but also 1 minus the square root of 15. We capture both of those with this notation right here. It's just a shortcut in notation. It doesn't really mean anything fancy. It's just a symbol that shortcuts the amount of writing that we have to do. Okay? So don't let these ones throw you off. Yeah, we're not to that one yet. Let's see. Yeah, okay. Well, actually, maybe we are. Let's go ahead and do one of these because these take a little bit more work. So let's take a look at this one. So this is an example of a homework one. What do they want us to do? Oh, yep, and here we go again. You can see that, don't jump to the whole screen here. You can see there is a plus or minus button. I was kind of thinking there might be, and then they give you a square root button because these are going to come up a lot. So let's do this problem. Let's walk through this one. This is more complicated than the ones we just did, but what I'll tell you is if you break it down step by step, like don't try to see the whole problem at once, just go step by step by step, you're going to be fine. So let's work through this. So 4 times x plus 9 squared . Four times x plus 9 squared. Was it plus 8 equals 32? Is that what it was? Whoops, how did this get all... Did I do that? Oh, probably when it expanded to the new screen. 4 times x plus 9 squared plus 8. 4 times x plus 9 squared plus 8 equals 32. Okay, got it. So let's work through this one. Let's see where this goes. Okay, so my whole goal is to get this thing that's squared by itself. So we want to get rid of everything else. Well, then I should subtract the 8 from both sides. Okay, that's not bad. That's an easy step to do. So 4 times x plus 9 squared equals, what, 24? Okay. Getting a little better. Now I got to divide by 4. Okay. See how we just did some basic simplifying. I mean, this was stuff from like early level math. I subtracted 8 from both sides. I divided both sides by 4. So even though our problem looks much simpler, we just used some basic algebra tools to get there. Okay, now I can apply the square root property. It's just like the one we did previously. It was a binomial squared equal the number. A binomial squared equal the number. So let's see, what am I going to do here? According to the square root property, this means that x plus 9 equals 6, or x plus 9 equals negative 6. Sorry, square root of 6. Square root of 6. Square root of 6. That's what I meant to write. So x plus 9 equals the square root of 6, or x plus 9 equals negative square root of 6. Okay, well, square root of 6, we can't really break down any further, right? Because it's just square root of 2, square root of 3. Nothing really going on there. So we're going to subtract the 9 from both sides. So this should become x equals negative 9 plus or minus the square root of 6. So if square root of 6 could be simplified, I would do it. It's like a fraction. You don't have to ask if you should simplify it. The answer is yes. Just simplify it. So let's see. Let's hope I didn't make some terrible mistake here. Negative 9 plus or minus square root of 6. So negative 9 plus or minus square root of 6. Ooh, got it. Okay. So let's see. They basically did the same thing. Subtract 8 from both sides. Divide both sides by 4. Same thing we did. And then we get to this. At this point, you go, oh, hey, I can use the square root property to get this. And then we just subtracted the 9 over to get negative 9 plus or minus square root of 6. So see how they also have it written this way? That's what I was referring to earlier, is I couldn't remember if they had you write it this way or this way. It looks like Delta Math is probably programmed to take both. So you can write it either way. But the main thing that I want you to do is recognize these are the same answer. This thing here is just a different way of writing these two answers together. Okay? If that makes sense. Okay? Yeah, so there's some videos in there, and then there's, of course, there's always, as well, there's also always the watch help videos. I know for some students that this link right here, it's like, you know, when we see something on a web page, enough times we sort of stop seeing it, like ads. You just sort of become blind to the ads and stuff. Make sure you're watching those help videos. They're very, very helpful in trying to complete this. Yeah. So yeah, if this feels like a whole lot and I'm putting a whole lot on you at once, don't feel overwhelmed. You will have the opportunity to go back, look at some of those short videos to work through it and sort of make sense of it. It's just I got to get information out when we meet so I can show you how to do it. But by all means, don't get overwhelmed. You can go back to just work through problem by problem till they start to make sense to you. Because I know this is an intimidating chapter. It's a difficult chapter the first time you do it, for sure. Okay, let's see. It does not make sense for me to try to cover completing the square in 8 minutes because it's a complicated thing, and I can't really cover it in 8 minutes. So I'll start next time with completing the square. So let me figure out what I should do with our remaining time. Why don't we look at another one of these? What's level 2 going to be about? I wonder, is there something here I want to see? What's different here? Not much. I think maybe this level 2 is just that you're getting fractions. That seems to be the only big thing here, maybe. Let's see. What about the next problem? And if we look at the solution. Yeah. So I think the level 2 problems are harder in that you're getting fractions. But see their solution in here? Look how long their solution is. So not to scare anybody, but this is what I meant, where the amount of writing that you're going to be doing for the types of problems is going to increase, but that's okay. Like, just break it down in individual pieces. In mathematics, unless you really know an area of math really well, you shouldn't be trying to see the end of the problem, right? You should be just trying to see, what is the next step? Can I just do the next step? That's all you should be worried about, right? Like, I see people just, they put all this stuff on their shoulders, like, oh, I got to figure out this whole problem. Just do one step. Oh, can I subtract 10 from both sides? Yeah, I can do that. Okay. Can I divide 9 on both sides? Yeah, I can do that. Okay. Can I apply the square root property? Yeah. All right. Can I simplify these equations? Don't try to do it all from start to finish. Like that, it's not an effective way to go through and work on those. Yeah. Yeah, so there's a number of helpful features that are inside the Delta Math here, between show solution, show example, and then the videos. So it can all be very helpful. And then, yeah, there are some videos posted in the actual Canvas pages that are helpful as well. So, don't feel like you should be walking out of today's class understanding 100% of what I said. It's you're not supposed to at all. I'm just trying to give some examples that you can come back and watch later and go, oh, I see what he's doing there. I see how he's working through that. So this is kind of a scary chapter. It intimidates people a little bit. It's overwhelming, but it is doable if you stick with it. It's one of those things where later on you might look back and go, yeah, those problems are tedious, but they're not nearly as hard as I thought they were when I was learning it. But when you're first learning it, it's a little bit scary. It can intimidate a little bit. So, all right, I'll just sort of set up where we're going next time. Yeah, I think I have enough time. I'll talk a couple minutes about setting up where we go next time, and then we'll go from there. So the next thing we have to learn is what's called completing the square. And completing the square is basically a way for us to put something in the right form. Remember I said a lot of algebra is taking something and putting it into the right form so that you can apply a formula. That's what this completing the square that I'm going to show you next time is, because we've just learned how to solve lots of problems that you didn't know how to solve previously. But for instance, this method is not, at least the way we've learned it so far, will not help you solve a problem like this. Okay, this equation right here is not in the form that we can use the square root property, because we're going to have this x squared. Remember, it's supposed to be x squared. Let me see if I can get this just right. It's supposed to be x squared equals a number. Well, we can't get this in the form of x squared equals a number because we have this weird 9x term floating around. So we're kind of stuck. We go, I don't know how to do this. What completing the square is a technique to algebraically take something like this and manipulate it into the right form that we can use the square root property. Okay, that's all completing the square is. Completing the square freaks people out. It scares them. They get intimidated. It's just some algebra so that we can apply the square root property. Okay, and once we do that, at that point we will be able to solve any quadratic equation. That's pretty powerful, no matter what, whether it's factorable, not factorable. Someone comes to you with a quadratic equation, you can solve it using completing the square. But we'll learn that next time. It's a little more in depth. And then the good news is after that, we will learn the quadratic formula. The quadratic formula is basically a shortcut for completing the square. So while many people find completing the square tedious and annoying and I don't like doing those problems, the quadratic formula basically jumps you to the solution without having to do all of the tedious completing the square parts. Now, that doesn't mean the quadratic formula is easy, because you still have a lot of simplifying to do when you use the quadratic formula. But you can see there's a progression here. Square root property, completing the square, quadratic formula. Without this square root property, we wouldn't have any of these three tools. None of them could exist. They're all built on the foundation of the square root property. So I just want you to understand that the things we do in the next couple of class meetings are extensions of this square root property is what we're doing. Okay, so with that, we'll sign off, and then yeah, you have some homework due, I think tomorrow is it? So try to make sure you get that completed, and then yeah, you have a little bit of time to start working on this stuff, and then we'll cover, what is today, Wednesday, so we'll meet again. I'll give you some more stuff on Monday. Oh, we meet twice next week, so Monday and Wednesday, and then that'll give you some stuff, you know, to think about over the Thanksgiving break, whatever it is that you're doing for Thanksgiving. So, okay, anybody who wants to talk to me in Zoom is welcome to stick around and chat with me, and we can discuss whatever you want to discuss. Otherwise, thanks everybody. Enjoy your weekend. Be safe, and we'll see you next week.